probably tell, actually a transplant from Germany. I was born in Canada. Most people don't know that, so I'm technically a German Canadian. I tell my American friends that I'm a spy, so that's why I sport this dialect, this accent. But anyways, I've been in San Francisco for a long time, and just, I guess like the rest of you, an enthusiast of the 10D machines. Joined this hobby a few years ago. And Pete invited me to talk a little bit about modern app development, and I'm going to share this slot with Lawrence, who will then take over about halfway through this time slot here. But I wanted to kick off the presentation by talking about how to develop apps for the TRS-80 using the C programming language. And if you have masochistic tendencies and you actually want to develop apps for the TRS-80, you have to make two fundamental decisions, I suppose. The first one is what programming language are you going to use? And the two obvious choices, at least back in the day, were BASIC. I mean, when I got my Video Genie back in Germany, that was the thing that just popped up when you turned on the machine. So it was kind of natural for me then to write in BASIC on the machine. Then after I saw the first Big Five game, it just blew me away. How could they possibly got this performance out of the machine? And that's when I discovered machine language, assembly language, and then I started to learn Z80. So that then is the next step that many people I know took in the field, start writing programs in assembly. Now, I think there are some other programming languages that even back in the day were available, at least on the Model 4 and the higher end models of the TRS-80, which I'm not familiar with, so you probably know more about that than I do. But in modern times, I guess, you have some other options. So nowadays, the second question you have to ask yourself is, how much pain do you want to inflict on yourself? Do you want to actually develop on the machine, or do you take the easy route and develop on a modern machine, cross-compile, and then transfer the CMD onto the vintage computer? Now, I have to be honest, I'm not the kind of person to inflict myself pain on this. I remember I wrote a bigger Z80 program back in the day, and it didn't fit, the source code did not fit in memory, so I had to break up my program into multiple sections, assemble one, manually copy down the symbol table, and then for the second batch of assembly code, then do a whole bunch of equates to then have the accurate jump targets. That's a very, very painful process, and it's definitely a lot easier to develop on the host and then even use a modern emulator like George Phillips' TRS-80 GP. You can test on the host before you move on to the vintage machine. But one thing that I wanted to talk about is using neither BASIC nor Z80. So the downside of BASIC is that it's just super slow, right? I mean, you can quickly hash out some programs, but you just don't get the performance as if you were to write Z80 assembly code. On the other hand, Z80 is also a little bit painful. I mean, if you want to learn new machine language, why not? That's certainly good, but it is just, if you just want to quickly write an application that has performance like assembly, but you don't want to go through all the hoops of writing in Z80 assembly, I think C is actually a very good choice. And what I want to talk about here is how to use the C programming language to write applications for the TRS-80. And I'm using myself something called SDCC, the Small Devices C Compiler. It's been around for a long time. I tried to dig out the history, and I found some traces going back to 1999, but I'm not exactly sure where it started. And but that's the tool chain that I'm using for my development. And I'm going to tell you a bit more about it so you get an idea on what it looks like to write code for using SDCC. So I copy-pasted the top portion of that from their homepage. The homepage is mentioned on the bottom. And so they do target not just the Z80, but they target a whole lot of microcontrollers. So it's a pretty versatile compiler that has come a long way. So also in terms of language support, you can see they go up to ISO C11 standard. So you can really write modern C code in SDCC. It excuse me. One important to keep in mind is that SDCC is a C compiler, but it doesn't, that targets certain CPUs, but not a certain platform. So when you download SDCC, it gives you a subset of the POSIX library, usually things that are just in memory. So APIs like memcopy, b0, stringlen, the usual suspects that you have at your disposal if you develop in C. But you don't have APIs like file system API, like fopen, fread, fwrite, fclose. I mean, because that obviously is dependent on the underlying operating system, which SDCC does not talk about. As a matter of fact, the runtime system, the CRT0, I will talk about later, for SDCC, for the Z80, just places the application on address 0, which on the TRS-80 doesn't work because that's where the ROM is. But it does support different hosts, so you can download it for Windows, macOS, and Linux, so depending on your preferred host system. It's licensed under GPL, and I think they use the same thing as GCC compiler, so while the compilers under GPL, the libraries are not, so you can create commercial applications using SDCC. The same deal with GCC. They also use GPL for the compiler and LGPL for the libraries. Yeah, the homepage on the bottom if you want to download it, so I'm sure Pete is going to upload the slides somewhere. And let's talk about CRT0. So that's the first thing you need to look at if you want to target a new system. So CRT0 stands for C runtime. I don't know why the 0 is there, maybe because computer scientists start numbering things at 0. But that is usually the piece of code that first gets executed when you run a C application. That is also the linker places that at the very beginning. So if you have a whole bunch of object files, then CRT0 is typically then put at the very beginning of the final binary. And like I mentioned earlier, the version that comes with SDCC just makes no assumption on the underlying architecture, so or the underlying operating system rather. So they just simply have an org0, and then they say, okay, that's fine now. So what you need to do is you need to modify CRT0 for TRS-80. So specifically, you have to look at different operating systems like TrisDOS and LDOS, and just include some conventions into CRT0 that make things work. And I have a version of CRT0 that so this is basically the modified CRT version that I then updated from SDCC. And so there are some calls. Let me just point out just a couple of things here. So for example, in the C programming language, you can have global variables that are initialized. So you can, for example, like in C, you can say int x equals 42. And the question is, what is actually initializing that code? So there's some initialization code that the compiler also creates during the compilation process. But CRT0 is then calling this setup function to make sure that all the global variables are properly initialized. And you can see they actually include like a little function here, a Z80 assembly code that does this initialization. But what is more important is then what I inserted here at the beginning. So basically that little bit of code here is mostly what I then how I patched or modified CRT0. And when you launch a CMD file from an operating system like TrisDOS, the stack pointer is already initialized to something that you should restore when you then exit at the end. So then what I do is I save the stack pointer. Then I try to find out if I'm running on the Model 1 or Model 3, and I use this very crude method of peeking into address hex 125, and if there's an I, then I know it is a Model 3, otherwise it's a Model 1. And there are two different memory locations where you can determine what is the highest usable memory. So these operating systems also tell you, how far can you go up in case you have some overlays or some other code in high memory that you don't accidentally overwrite that with your stack pointer, for example. So then, depending on what machine you're running on, I retrieve the highest usable address, load it into SP, the stack pointer, and then here, that is part of SDCC. It calls the global initialization routine, and then here is where you actually then kick things off by calling the main function. You know, the main function is the entry point of any C++ program, but it's just a regular function. So you call it like any function using the call Z80 assembly instruction. So when you come back, you will have the return result in HL, and you can here what I do is I put it into DE because I think that's what TRS-DOS expects the return code to be. I restore the stack pointer, and then depending on if main returns 0 or not, indicating the program was running okay or there was some error, then I exit via two different jump targets. And there was actually discussion on Discord about that a while ago, and I just believed whatever the expert were saying there, and I just copied these jump addresses in CRT0. But that's basically the startup file. It has to be written in assembly, and again, the linker puts that at the very front of a CMD file, and all the rest from here on can just be written in C code. So let me go back to my slides. So I wanted to show you some important things that are important, especially if you want to do inline assembly. There comes a point, I mean, you cannot write everything in C, right? I mean, there's some memory mapped I/O that is easy to do, like, for example, screen output, right? You can just use a pointer to a char to point to 3C00, the start of the top left corner of the video screen, and use C pointers to manipulate the screen memory. That works fine. But then, for example, if you want to do input-output of the expansion interface, so the Z80 instructions in and out, there is no C instruction where you can then write just pure C code. So at that point, you have to do inline assembly. And one thing that you have to then understand of a compiler is the so-called application binary interface. Basically, how does the compiler what are the conventions for passing parameters down to a function? And I'm going to use this very simple example here. So as you can see, I have a function called add. It just takes 2 ints as a parameter, and all it does is compute the sum and return that. As simple as it can get. And then from the main function down there, I just simply call add 3 and 4. So the result should be 7, or will be 7. So I'm going to show what then the generated assembly looks like, and that will also show you then what the ABI looks like. What are these conventions that are used to pass parameters down? And one interesting thing is that if you download SDCC through your favorite package manager like Debian, for some reason they have a fairly old version of SDCC 3.8. That is not the most current version, and I'll show you what actually the ABI looks like with the latest version. Because if you look at this here, you may say, "Oh my God!" You know, like the simple x plus y results in like 24 lines of assembly code. That cannot be right. But like I said, SDCC has come a long way, and the first versions they did what usually C compilers do. So let's start with the main program here. So in C, usually parameters are passed on the stack. And if you look at the main function here, they first push 4, and then they push 3, which are the 2 arguments, and then they call the add function. You can see my pointer here. One little trivia question, does anyone know why parameters are pushed from right to left? If you remember, I had the add 3 and 4, but actually if you pay attention here, they first push 4 and then push 3. It's kind of a...
Well, the stack is last in, first out, right?
No, you could also do that. Yes, of course, the stack rows to lower addresses. Well, it's actually a very tricky thing. Like in C, you have these ellipses, these variable number of parameters, like printf, for example, makes use of that. But you need to have the first argument needs to have a constant offset. And for that reason, you have to actually push them in reverse order. Otherwise, you wouldn't know where's the zeroth or the first argument, you know, if you don't know the number of arguments. So that is actually, if you look at any C compiler, they push the parameters from right to left on the stack. And the reason is this variable number of parameters. But anyway, so that's what SDCC did in the early days, just did what every other C compiler is doing. And then if you take a look at the generated assembly code for the add function, and of course they have to then peek into the stack to retrieve then those two arguments, 3 and 4. And that is what you see here. So the 4 is actually not the parameter here, but the 4 is the offset. Right? If you think about what is on the stack at this point, you have the return address that resulted from the call instruction, and then you have those two arguments, 3 and 4. So what they do here is they basically jump over the return address and also the first parameter to fetch the second parameter. They pull it out, they use even like the index registers here, they pull it out byte by byte, do add and add with carry. I mean, it's just horrible, horrible, right? But that is how you would do if you were just to follow the what every other C compiler is doing. Now, for a small device like the Z80 or with little memory, that is not very efficient code. So if you download the most recent version of SDCC, that is what it looks like. And what they've decided there is if you have a fixed number of parameters where the compiler can use registers, it will do so. It will not use the stack. So you can see here that the main function, oh, I forgot the call instruction here. So it actually is using DE and HL to pass those two parameters. And what I forgot here on the bottom is the call to add. So they're no longer using the stack. So much more efficient. It makes sense. You know, if you don't have variable number of parameters, if you don't use ellipses for a certain function, why go through the pains of pushing parameters onto the stack? So one little takeaway is if you want to use SDCC, don't use your favorite packet manager, but do download from source and then use the latest 4.2 version that has a much more efficient code generator. But I'm okay to answer questions anytime in between, so just raise your hand if you have questions. The next thing is that, like I mentioned earlier, is that how do you do inline assembly? And that is pretty easy. So on the left, I just show you how to inline assembly. For example, to do things like calling ROM routines here. So there's a C function called getKey, which gets a key from the keyboard, and I just use the ROM routine that is at hex 49. And the way to do that is just by having __asm and then ending it with end_asm. And that piece of assembly code is just simply then copy pasted into the generated assembly program by the compiler. Now here there are no parameters, no input parameters to get key, but you have to put the result in a certain register. That is where the ABI comes into play again. Like you have to know where SDCC expects parameters to be and how results are being returned. Now this piece of code here is for SDCC 4.2. So since the ABI changed between those older and newer versions of SDCC, so that piece of code will actually not work on the older version of SDCC, so that you have to pay a little bit attention to that. On the right, I show you, so SDCC does actually have some meta instructions that a regular C compiler would just barf at and give you an error. So for in and out commands, for example, you could do inline assembly, like, right? I mean, if you know how parameters are passed, and since you know now you can do inline assembly, you could just then do like C wrapper functions for in and out. But SDCC actually, for these things, offers a more efficient way. And here's the piece of code that a regular C compiler would just barf at and just say that's not right. But SDCC in this case actually interprets this as this variable or the identifier Tris.io port to point to an I/O port, not to a memory address. And then what you can do is you can just simply use C, say Tris.io port equals val to write something to that I/O port. So here SDCC would be generating an assembly instruction out with whatever value that you pass here. And likewise, if you just dereference it or if you use it for reading, then it will generate an in assembly instruction. So this one line here, if you know it, then it's good. And from then on, you can just very simply then use these regular C code as if you're using a C variable. Port 1F is port 31. That is the Tris.io port. So that code I also just copy pasted from some of my Tris.io code. Just to show you and then I just created these little wrappers here, out to port 31, input from port 31. Now, I mentioned earlier that SDCC comes with some in-memory libraries, like the common POSIX things for string compare, string len, and copy functions. So they have quite a bit. They also have a printf function where you have to provide a put char implementation, like a function called put char that then does something on the platform. But beyond that, there is nothing there. And when I wanted to write an app for the TRS-80, I thought, well, okay, so what else is missing on the TRS-80 to write maybe also visually compelling, let's just say, application. And I decided to work on what I call Trislib, and that's the last thing I wanted to just present and talk about before handing over to Lawrence. So Trislib began its life for the RetroStore client. So some of you know there's this thing, RetroStore. We'll talk about that also tomorrow during another talk. But I developed a native client that runs on TRS-80 on the machine. And I wanted to not just have like a command line console application, but I thought, you know, in the age of smartphones, you know, where everyone is expecting some cute animations, I thought, well, why not just try to do something like that that gives you the ability to write some visually more compelling applications. And the result is Trislib. I refactored it into a library. It's on GitHub. It's open source. On the bottom is the link to the source code. And I thought I'd just give you a quick demo on what it looks like. Okay, Lawrence, where's your... okay, so I got it. So I'm using a patched version of SDL TRS that I hacked some time ago to integrate Tris.io. I can also do some specific things that are Tris.io specific, but I also included Fret. So here I'm booting up new DOS. And here I'm calling it Trislib demo. So this is what you would normally see then on the machine. And it's just a little demo that is also, you just saw like this animation coming in here. So if you then click on about, so there's a menu here you can select. And then it kind of scrolls in and it shows you, you know, what it's about. And if you hit escape, then it kind of goes back. There's so this here is a menu, so you can just give it like an array of strings and it will automatically format this to a menu and it will handle all this key up, key down. There is a form thing here where you have some input options, so like a simple yes, no. Here's like a drop down big, so you can just, for Pocket Tris, for example, I have, you can choose the screen color, so you can just simply, you know, pick whatever color you want. Down here, there's for text input. So it just kind of like makes it easy to quickly put together an application. So all this formatting, like aligning all the fields, and all Trislib does that. So you just give it again an array of input elements, and it will figure out, you know, how can it neatly align and does all the right things. Trislib also contains a C API to Tris.io. So for example, the Trisnik API that Pete contributed to Tris.io, he contributed Whois client. So I also then rewrote that in C with the API that Trislib offers. So here I can just type in a domain name, and it will now use a socket API to query the Whois server. So it's basically, if you look at the source code, see, it's like a socket. You know, it doesn't look exactly like a Berkeley socket, but it's the same idea. You just open a socket, you send your command, you can read from it, and it gets all the result back. So that's the socket API. There's also TrisFS file system, and you don't have a text file there, right? So let me just go back here. Let me just echo. So I'm on the MacBook here. I'm creating a file hello.txt with, you can see hello TA22. And then this demo here, you can basically, there's like a file system API where from within the TRS-80 you can access files on your SD card, SMB share, wherever, like if you use Tris.io, you have SMB share. So it also has a nice, easy to use C API for that purpose. And maybe the last thing I'll just, before I jump out here, is I have the, so here it is the library for Trislib. And here's the demo I just used. So here's the source code of the demo. So for example, the main function here, you can just see what you have to do, and you can see just like some pretty simple C code, like a struct that has all the menu options, and you just call like a function show display menu, and it will do all the animations. So here is the form example with the so here's basically like another struct where you can just define what the form should look like. You have like checkboxes. You have headers if you want to just visually just create like a section. You have a checkbox input field. So you have basically like the elements you just saw in the demo earlier. And then just at the very end, here's the Trisnic demo in C. So first the form to enter the host name, and then basically it starts here. So here's basically the call where you create the socket, and then you can see then you can connect to it. You send the string, and then here's the loop where you read from the socket. So basically there's a C API, a nice C API from within your TRS-80 machine to then do some simple socket communication. So there's still stuff missing in of Trislib. So command line parameters I don't do, like the argc, argv, but I just need to figure out how these parameters are passed down on the common operating systems. Also, one thing I want to do is to add file system API for the native operating system. So Trislib, for example, TrisDOS or NewDOS, right? I mean, that actually have like an fopen for TrisDOS or NewDOS. And then you could actually also do something like import-export. Then you can use then TrisFS to copy files, like what the import-export tools do for Fred. So it's kind of the next thing. So I do want to add more API to Trislib, and it's open source, so feel free to do pull request. Always happy if someone else helps to enhance the code. Yeah, and that is the end of my presentation. Paul?
Question. On Trislib, when you're doing the menu system, are you doing DirectX to video memory?
Yes, 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 yeah. So
Is there a pair API?
no, I don't. The only ROM I use is the get character, get key. That thing I had as an example earlier. That's the only ROM routine I use. Everything else, I mean, these animations, that is just. It automatically detects also for model 4, it will also do the 80 column, so it will automatically rearrange itself. It has this pixel font in there, like an 8 pixel font size for these headers that I show that show you the title. So, but it's all in memory. Other questions? Yes. Sorry.
Does SDCC allow you to use dynamic memory allocation?
Yes.
Did you have to set up somehow something to TRS-80's memory?
It starts with the heap after the data segment, and I never looked into what happens if you go too far. Like stack canaries and stuff that doesn't exist on the TRS-80, right? So probably you could maybe prevent overwriting your stack, but if the stack goes into the heap, so I think it just continues. But I haven't. There's a malloc implementation, and I never bothered to see when it declares out of memory. Maybe you can set a hard upper bound, but never ran into that. Yeah. Other questions? Paul?
Yeah, I guess since you didn't implement it, but maybe it's like is there scaled down versions of printf and stuff like that?
Of what?
Of like printf and stuff like that.
Yes, yeah, printf is there, yes.
But is it scaled down? I mean, a full printf implementation
Yes.
never fit
Yes, yes. They have different flavors of printf where you can decide on how crazy are your format strings, and you can then pick and choose. But I have to say, especially with the 4.2, so I did some size comparisons of the RetroStore client, and the size difference is significant. You know, so definitely do use 4.2 if you want to do any SDCC development. Okay, I don't want to take any more time away from Lawrence, so thanks for your patience.
Hi. So my name's Lawrence. I was here last year, and everybody was working on all these super cool projects, and I was thinking, what can I do? How can I contribute, and all these things? And I was really inspired by all these people who were writing modern games for the TRS-80. Like Kyle was writing that state game, and then Pete, of course, is writing the Roundup games, and this is all in assembly. And I looked into how that was being done, and it was being done sort of the old-fashioned way, where it's like you write in a text editor, and then you shell out, and then you run the assembler, and then you have a command file, and then you stick that into an editor or something. And that's how everybody used to work, 10, 20 years ago, and then like more and more people now use IDEs, these integrated development environments. The idea of an IDE is that instead of having an editor and a compiler and a debugger, maybe as separate programs that you have to use yourself, you have a single program, and the editor's in there, and the compiler and the debugger. So I thought it'd be fun, and maybe kind of interesting to write an IDE to write assembly language for the TRS-80. And it's just like the most useless program ever. Like maybe 2 people could use this, but I don't know, I thought it'd be fun. And I want it to be really approachable, so instead of downloading some software for Windows or something, I just made it web-based. So you just go to a website, and it's just there. And I already had this website, which I showed on, I think, Trash Talk Live. mytrs80.com. And the idea behind this thing is that it's supposed to be sort of your virtual machine, because I don't collect these machines. So I just wanted to have like my TRS-80 as if I had a physical machine with a library, and you can just like go there and you can import all your diskettes and programs and cassettes and stuff. So for example, right here, you can bring up this thing. This is all the stuff I've imported from in my own account. So feel free to get an account. You just sign in with your Google account, and then you can just start uploading your floppies and just using them, and it just feels like your own library. So I already had this thing, and then if you go there and you add /IDE to the end, then you get this IDE. And what it looks like here is you have on the left, you have your editor, and this is where you type your assembly language program. And on the right, you have an emulator that's running all the time. And then you just write your code, and it runs on the emulator. So there's not like a separate like assembly step, and then you copy your program or whatever. So for example here, let's start at 8,000, and then we'll just loop. And as I'm typing, it assembles like with every keystroke. And then so on the left here, you see 8,000 is this number here is the address of that instruction, and then you see C3, which is jump, 80, which is a jump to itself. And then so you can, let's say load HL 360, 191, and then I can write A to HL. 15360 is the location of the screen in memory. And then, so here I can type A. And as I typed A, this block showed up over here. So every keystroke, it reassembles the whole program. It takes the virtual machine, restores it to a clean state, including all of memory and everything, and then runs your program on it. And then so there's no risk of damaging or anything. Like if I forget this stop and it runs off the bottom, for example, if I delete this, it'll run off the bottom and sort of destroy memory. So like the block isn't even there because it draws the block and runs off the bottom memory, goes back to the ROM and crashes the whole machine. That's fine. As soon as you fix it, the block comes back. So there's no risk, and you just keep going and keep typing. And if you're writing an error and then there's an error in the code and it trashes stuff, just keep typing and fix it, and everything's good. So here's, for example, load 10 into B, and then we'll have a little loop here. So we'll increase HL, and then one of the nice things, DJ and Z loop, right? And then so now you're drawing 10 characters. You can go over here and then change that 10 to 100. And as you change between the two, it goes back and forth. So you get like very fast feedback on what you're doing, which is pretty great, especially when writing games, because you want to see like how things change and like timing of things or how things feel. And so the quicker the iteration on doing that stuff, the more you can sort of fine tune and polish your software, which is pretty nice. Yeah.
Are you taking questions?
Yeah, sure, go ahead.
Can you turn that off? I can imagine if I'm writing like file I/O or something, I wouldn't want it to sit there
Right.
and pound on.
Yeah. Yeah, so the question was, can I turn off the auto run? And that's over here in the run menu, you can just turn that off. And if you do that, then there's a command R to just run it manually. Yeah. Right, exactly. So one of the things that I struggle with Z80 assembly is that I don't know it, right? So it's like, what are all the variant ways of adding something? You know, so you type add and then autocomplete, and it'll show you all these different things. So it shows you all of the add instructions, and it shows you on the right-hand side just a little blurb about what that is. So for example, I don't know, SLL or something, it's like, what does it do? It's like it shifts, is that the one that goes through the carry bit or not go through the carry bit? Or as you autocomplete, it'll tell you what those things are. So you can get sort of, and it's pretty great for just learning assembly pretty quickly. And the nice thing too is that it doesn't just autocomplete the name of the command, it'll autocomplete anything in the instructions. So like if I forget how to shift at all, I can type shift, and it'll show me all of the instructions that involve shifting, and then I can go through and choose the ones that make sense. Or I can, shift right or whatever, and it'll show me all the shift right commands. And then once I autocomplete one of them, then it'll replace it with whatever that is. So that's nice for like as you're typing. And the other thing too is that sometimes I forget things like how fast instructions are or certain details about how they work. So if you hover over an instruction, it'll tell you the full description, how many clocks it takes, and all the flags and how they're affected by that instruction. Like for example, this one here will show you that it's 8 clocks, but if you actually does a jump, then it's 13 clocks. So you can sort of, it's pretty quick. You don't have to look at each one up one at a time. When the program gets pretty big, it can be hard to follow things around. So like for example, if you're in this loop thing, you can just jump. It's hard to tell, but it jumped to the declaration. And then when you're on the declaration, it'll jump back to the call, so you can go back and forth between all the labels and where they're used and cycle through all the uses of the labels, which is pretty nice because, like, as you know, like assembly is all go-to based, so it's extra useful to be able to jump back and forth between all these different labels. Okay, so that's a simple thing. It comes with a bunch of examples. I call this Space Invaders, but it's really like a little dude that just goes back and forth. And so the idea here is that it draws it, and then there's a delay loop at the bottom, and it's going pretty quickly, but you can sort of like mess around with the delay, right? And be like, yeah, that seems about right? So that's how fast it is to sort of iterate through all that stuff. Another thing that's useful when you've got a bug or something is to set a breakpoint. So you click on that, and then it breaks the emulator at that location, and then you've got down here the state of the Z80, all the different registers, and some information like the stack shows you what's on the stack, the PC shows you the instruction, and the flag shows you which flags are on or off. And then you can single step through that, and it highlights in red what's changed, so it's pretty easy to see. For example, HL right now is pointing at the screen, and it tells you that it's column 1, row 1, column 28. So it sort of like helps you figure out what the heck is going on with your program. And then so you can go like that and single step through the whole thing. The other thing that you often want to know is how fast are each of these instructions, right? So you can hover over them, and it'll tell you, okay, this is 6 clocks, and this one's going to be 10 clocks. But sometimes you want to know that more. So here you've got on the left, you've got the address, and you've got the byte code, and you can show and hide all of these things. And another column that you can show is timing.
and for each instruction here, it'll say, for example, post straight child is 11. And then after that, the next one is 10, and then show cumulative times over here.
These are T states. And they reset at at the top of every loop, so that you know, for example, that
At every label. So for example, you know that all of this will take 91 T states.
and that's pretty nice for just knowing. You can try different. Sometimes there are 3 or 4 different ways of doing something. You can try them all and see which one is actually end up the fastest of the different T states. So another thing that is pretty common with Z80, with TRS-80 programs, is that you've got some kind of splash screen, like breakdown or something, or any of these things usually have a splash screen. And the way that those are represented inside a program is usually some kind of, hold on. The way those are represented inside a program is usually like just bytes, like the actual graphic characters are just hard-coded right into the program. So you might write like 191, 131, 131, 191 or something, and that's some kind of like graphic thing. And you've got just 1,024 of these for the screen. And do you remember those like blue pieces of paper that had the grid, and then you would like fill them in and then figure out, okay, do that and then type in all this stuff. I thought it might be useful just to be able to edit those directly right in the program. So what you can do here is you can type a comment, you could say screenshot, and when you do that, it detects after that all the bytes that came afterwards. It figures out that that's a screenshot, and then an edit button shows up here. And then so you click that, and it loads that into the emulator, and it provides a pretty full-featured paint program. So for example, I can just like, type here, then when I click OK, that gets written back to the program over here. And so the paint program can do all sorts of stuff. You can, the lines and stuff in that, including like this. You can hold Shift. This is a fun thing. You could you can hold Shift as usual, like in paint programs. But on TRS-80, pixels are rectangular, right? So there's 2 definitions of 45 degrees. There's this like the pixel 45, and there's the actual 45, and it'll do both of those. The things. You can do ovals and circles and all that stuff. You can do a bucket fill, text, and there's the regular like copy and paste and stuff like that. So you can, for example, you can copy that and then move it around and do stuff, right? And then often you have like mirrored stuff, so you can like mirror things left, up and down and all these things, clear it, reverse it. And there's infinite undo and redo. Oh, and this is fun. So here's a grid. So this is the pixel grid. And then here's the character grid, right? And when you turn them both on, then it looks like one of those little blue things that I had when I was a kid. So like, I kind of wanted that, just to look at it. And various other things, like you can have a cursor so that. Can I download? So the question was, can I download the code? And all of this stuff, you can certainly copy and paste from the website. And then, I'm not here yet, but I would save to it currently saves to your own local storage, but you can download a zip file and stuff like that. But ultimately, you would save it that way.
Does it also do model 4 mode?
Does it do model 4 mode? My emulator does do model 4. It has some support for it, but then it's not full featured. Yeah. So I think that's it for the paint program. And so what's kind of fun is to, for example, I disassembled breakdown. So you can just play it here, and you all know this game. And then, so for example, I'll rerun it, but he had to, presumably Pete had to do this by hand. But there's in the disassembly here, at the bottom, I figured out where that was, and I put the screenshot here. And you can put an end screenshot afterwards if it's fewer than 1,024 bytes. So then you do edit, and it dumps you into the paint program. We can modify this, I don't know. Presumably it's trademarked
So we'll just do that. Right. Yeah. And then when you run it, then it's you just get it back. Yeah, I also want to show you just how, like, the compiling speed. So here's, it says Peace Keys software. So let's say I want to change that to lowercase. So, like, it takes, like, reassembling all of Breakdown takes about, so reassembling it all, resetting the whole machine, and setting it all up and running the program takes about 40 milliseconds. So it's pretty fast, pretty interactive, even for a reasonably large program. Here's one that I played when I was a kid. Now, it always bugged me, even as a kid. Why is there a $sign there? It's like I don't know what that is. Like, it seemed like they could have just closed that thing. It's just like there's something about that that just rubbed me the wrong way. So now I can solve that. Here's the maze. So it's not just splash screens, right? Mazes are good for this too. So here's the thing, and we just go in here and just like close that and finally, like, and so 40 years later, I finally get what I want. It was just to get rid of this super $sign. Yeah, right there you go. Exactly. Yeah, exactly. So, but while we're here,
You created several monsters.
yeah. So while we're here, though, you know what makes Pac-Man hard is these ghosts are really annoying. So it turns out you could just block them in, and it's way easier. It's way easier to play like this. I don't know. I don't know why they didn't just do this from the beginning, because it's like they should just done this. Okay. Here's for example, what's over here? Yeah, so I don't know. There's different things. So you could just do various things, right? Like that stuff, right? And then when you do that, it just shows up. Two interesting things about this. Maybe somebody knows. Yeah, so you saw that. So here's the maze, which takes 1K, and above that there's another maze, and above that there's another maze. And so if I edit this second maze, it looks like this. This is what's in the program. I don't understand. Yeah, and fix that. I don't know when it comes up. Does anybody know? Like, does this ever come up during play or like during demo mode or something? I don't know what this is. And then, yeah, well, it's weird. So here's the first one, which is it's the same maze but with the ghosts and with Pac-Man. So, but the dots are in the same place. So.
Could it be part of the track mode? Does it have an attract mode where if it's just sitting there idle, it'll show?
It could be an attract mode, but the way when you run it, it just like all it does is it does this, and then it launches you into the game. So, and then you lose because you get, and then it just hangs there. So I can't find an attract mode there at all. And the whole program's like 7K, and 2 of those K are these 2 screens. So it wasn't an accident, right? They really wanted those 2 screens, and I don't know what they're for.
Yeah, maybe it was something they used during development or something they used for debugging.
It could be for debugging, but there's other strings in there that I don't know where they come from, like high scores and stuff like that. So, but there's a high score thing, so I've not sufficiently gone in there. But that was an interesting find, just going through and doing that.
Did you backtrack the label or the?
Oh no, I didn't. I haven't reversed it to figure out where that comes from. What's that? Well, it could have been a mistake, but like again, it's 2K out of 7K. These guys are probably not doing that by mistake. It's probably some feature that I'm just not triggering somehow. Like you said, it's like a demo mode or whatever it is, but it's static, right? It's not even running, it's just static. Yeah, so I don't know. So I figured that out. And so just to try it out, I started to sort of, I wanted to do something myself, like write a new game from scratch to test it. And I didn't get very far on this, but there's a classic Wolfenstein 3D game from the early 90s. And so I just barely started on it, so all you can do is go left and right. But it was kind of useful to go through and look at the timing and do dots. And so I'll still keep working on that, but I couldn't finish it by TA. Okay, so that's that. And since that's the IDE, so let's just go to mytrs80.com/IDE and you can just start programming. And since we're here, and I'm going to so this whole talk is about modern TRS-80 development. As a kind of as a joke, so this is my TRS-80 thing. I wrote a Forth compiler because I thought, because Forth is this ancient language from, I don't know, maybe 60s. And so if you want to, and if you know Forth, then it's actually easier to do Forth than assembly for sure, and it's way faster than BASIC. I don't know how it compares to C though. It's probably slower than C. But the way Forth works is you've got a stack, so to 5, it pushes 5, and then you add 6, and then you do a plus, and then it adds them all together. And then you can do things like, I added a graphic, so you could do it's set like a pixel there. So for example, you can draw this. So it's like, it's way faster than, this is like a built-in demo. It's way faster than BASIC by a long shot, but not quite as fast as assembly. So if you know Forth and you want to do modern development in Forth, that's available to you too. That's it for this part. Any questions?
Well, how, when you grab scarf man and breakdown, you know, how are you uploading the software to the website and vice versa? How do you download it?
Right.
Just copy and pasting?
Yeah. So the question was like, how do you get software in and out of it? So currently, like I had to get the demo working for this, so like this is not quite awesome yet. So what I was doing for the most part is just copy and paste the whole thing into some other thing, like into an editor or whatever, when I was done with the day, and then putting it back. It will actually save it. Like if I refresh this page, like I can make, no. If I refresh this page, you won't lose anything. It'll actually refresh it properly, but it won't. If you actually want to save it to your own computer, you just select all and copy paste. But the next thing to do is to save it, like either download it as a zip file, or save it to local storage, or to save it to your local machine or something.
So uploading, you use the disassembler in an emulator and just
Yeah.
copy?
Yeah. So for uploading, exactly, you just find some way of getting the assembly, and then you copy paste into it.
Your assembler is, in your IDE, is compatible with pretty much standard TRS-80?
Yeah. Assembler compatibility is an interesting question. My assembler is, I just sort of modeled it after ZASM, which itself is sort of trying to be, support like the union of all Z80 formats. So it handles a lot of different cases. And then I didn't try it with, I don't know how close it is to ZMac. I think a lot of people here use ZMac. But Pete gave me his, the original source code of Breakdown, and there were only 2 little things that didn't work, and I fixed those in the assembler, so now it handles those 2. So I think they're pretty compatible with ZMac and ZASM, but if it doesn't, I can always just fix whatever you find if it's not.
Like I noticed with your directives, like with org and with DB, you had dots in front of them, and
Yeah.
the legacy TRS-80 assemblers don't support that.
Exactly, and so the question was, do you need like a dot? I had org 8000, but it'll work without the dot. So I
Also, denoting a hexadecimal number with an H on the end will work
Yeah.
as well. And
Yeah,
just-
yeah.
Okay.
That and
Because again, legacy disassemblers.
yeah.
aren't
So
gonna use
exactly.
zeros.
Exactly. So it'll work. It tries to handle the union of all the different things. So the H at the end, the $ sign at the beginning, the 0x. It also there's various things like loading DE into HL is not actually an instruction on Z80. So there's a bunch of a lot of assemblers will support those, and I support all those as well, including I think that's this is an undocumented instruction. So it's like it's not an official instruction, but it handles all those in documents too. So I think it's pretty full featured, but I've not really battle tested it with. Say it again.
Macros?
It has some, it supports macros. It's a little weird in here, the way that macros works, because it shows you the thing, right? So you say, let's say, foo macro. I forget how you even do macros. How do macros work? I forget. It's been a while. It's the fastest way to figure this out. Sorry, just real quick. No, that should worked. Oh, here we go. Okay. Okay, so it's hard to tell, but like the macro has one instruction, a no-op, and the address here is 8000, and the address here is 8003, but that first instruction only has 2 bytes. So this macro did work. It's just that I don't actually show the output of the things, but yeah, the macros work. So there's more work to do there with actually like showing what the macro expanded to, and maybe even showing like what the instructions were and stuff like that. But it supports macros, yeah. That was a question too. Does it work without an internet connection? It should, yeah. I mean, it doesn't use the internet after it's downloaded. And then so I should be able to package it up in a way which is entirely local. I think I should be able to disconnect now and be fine. It doesn't hit the internet after that, yeah.
How solid is your FTC support in your emulator? I mean, if you're writing software that's doing low-level disk access.
Yeah, how solid is the disk access? I think I do read-only right now. I only do read-only, but it works like in here. You can, right, you can, so, but it's, yeah, I think I only did reading. I didn't do writing, yeah. Mostly because I didn't need it for myself. I was reading my own floppy, so I didn't need it, but. Anything else? Yeah.
So you use the assembly development environment with a running OS or no?
I've not tried that. I've not tried, so the question was, can you do with a running OS? I've not tried that. I've only tried it like with a cassette, like a blank cassette boot.
In mine, I'm thinking like a saved virtual machine, so like you get to a boot up state or something like that. And then,
Yeah, so the question is like, can you get to a boot up state and save it, like get pretty far here with, let's say, booting a floppy or something, and then continue from there. There's a related question where, like, if you're writing a game, you might have, the splash screen, and then you get to like level 5, and then you get pretty far into level 5, and you're tweaking something there. Like, how do you iterate on that quickly? And I don't have a good solution to that. Yeah, I could try to save the state, but really that state is very fragile because, like, if you change anything about your program, memory locations will shift and variables will shift and stuff. So I'm not sure how to do that in a robust way, but I think that's clearly an important feature. Yeah. 8. Thank you. All right. Okay, guys, thank you. Thanks.